Calculate the initial moles of hydroxide ions, OH to the power negative, added, using the volume and molarity of the NaOH solution. Moles of OH to the power negative equals volume, L, times molarity, M, equals 0.200 liters times 2.0 moles per liter equals 0.40 moles quad. Calculate the initial moles of hydronium ions, H to the power plus, present, using the volume and molarity of the HCl solution. Moles of H to the power plus equals volume, L, times molarity, M, equals 0.500 liters times 1.0 moles per liter equals 0.50. Moles quad. Determine the stoichiometry of the neutralization reaction. Since HCl and NaOH are a strong acid and a strong base, they neutralize each other in a 1-to-1 mole ratio. H to the power plus plus OH to the power negative gives H2O. Identify the excess reactant and calculate the remaining moles. Because the moles of H to the power plus, 0.50 moles, exceed the moles of OH to the power negative, 0.40 moles. The OH to the power negative is the limiting reactant and is fully consumed, leaving excess acid. Remaining moles of H to the power plus equals 0.50 moles. 0.40 moles equals 0.10 moles quad. Determine the total volume of the mixture. Add the volumes of the two solutions. Together, total volume equals 200 ml plus 500 ml equals 700 ml equals 0.700 liters quad. Calculate the final molarity of the excess H to the power plus ions. Divide the remaining moles of H to the power plus by the total volume of the mixture. H to the power plus equals 0.10 moles over 0.700 liters equals 1 over 7 molar, approximately 0.14 molar. Calculate the pH of the mixture. pH equals log H to the power plus equals log 0.14. Mental math estimation. Since AH to the power plus of 0.10 molar corresponds to a pH of 1.0, a concentration of 0.14 molar, which is slightly higher, will have a pH slightly lower than 1.0, specifically, pH approximately 0.85. This is closest to 1.0, which matches option A. The correct answer is option A, 1.0.